Okay, and welcome to my presentation about building Qt5 user interfaces with the MACHINEKIT SDK. First, I will talk about VAGRANT, which is a thing I recently discovered. Then about QTQUICK, it's only a short overview. Then actually the SDK and future options for this SDK. So what is VAGRANT? VAGRANT is sort of like an application that works together with with virtualization software like VirtualBox or Parallels or VMware. It basically offers a way to easily configure such VMs. I think I've created a VirtualBox with the Qt stuff inside last year or so, but the problem with is you can't keep it up to date. It's even if you have a VirtualBox, it's hardly to reproduce a recent state, a common state, and yes, it does not work very well for different machines. So VAGRANT is a thing that tries to simplify exactly this process. It's basically designed for developers, especially web developers, to reproduce web servers and so on. But it's not too hard to configure it in a way that it works with graphical user interfaces. Yeah, it's portable. It's available for all major desktop platforms, and it's maybe a way to get rid of all this works on my machine or does not work bugs that we have seen on the MACHINEKIT mailing list so often. Yeah, then we have a virtual machine. I use VirtualBox for this, so VAGRANT works in combination with VirtualBox. It runs a chassis image. VAGRANT has a base chassis image, which is very minimal. It's only a very basic installation. So we have to install LXDE, the MACHINEKIT packages, the Qt SDK, and a set of repositories. And in addition to that, like a few branding things that it looks like MACHINEKIT and so on. Yeah, so let's go to QTQUICK. What is QTQUICK? It's basically a plugin for QTQUICK QML. QML is the user interface description markup language of Qt5, basically. It is actual QML is a programming language that works in combination with QTQUICK, and QTQUICK is something like the Python base modules or standard I/O or something like that. So it's basically the base libraries that are provided with the Qt SDK. And QTQUICK is basically a set of QML plugins that extend this QTQUICK basic functions. It uses the machine talk API, meaning it uses CRMQ C++ bindings. It uses the protobuf C++ classes, and it's meant to be a cross-platform UI design language. You get the SDK for all major desktop platforms, and you can target almost everything that runs the user interface. One important design decision of QTQUICK is that you can remotely launch and deploy new instances. The QML files are basically source files, so it's easy to deploy these files to a client computer machine, and the QML interpreter translates it into bytecode and executes it. So it's completely platform independent, and you only have to have a single client on your UI computer, basically. This can be a tablet, this can be a desktop computer, it can be some kind of embedded device. So meaning that's one of the ideas is having a single client for all user interfaces. This gets rid of all the Android deploy problems, for example. It's not too hard to deploy an application to Android, but it's like you basically have to be a developer to do it. You have to have a credit card to get it in the market and so on. It's not that easy. Yeah, and this single application, client application is the MACHINEKIT client. It basically contains all the QTQUICK modules plus the QTQUICK VCP modules. So it's like a big application with all the plugins that are available, and it interprets the QML code for the user interfaces. There are typically two types of user interfaces you can design with QTQUICK VCP. One thing that I've already presented last year are HAL remote user interfaces. These use only HAL remote components. The second type is the typical Linux CNC application, which we've called it application, meaning it interacts with the EMC module, meaning MK wrapper, and so on. So typically two types of applications, HAL remote or application. In the future, we maybe get everything in the HAL remote type of application. But currently, for when you want to design like a CNC user interface, you need the traditional MK wrapper client, basically. Yeah, let's take a look at the SDK. The MACHINEKIT SDK is basically a set of several wizards for Qt Creator. It has some plugins for Qt Creator to preview, for example, the BBIO, BeagleBone, Standard IO, Universal IO files. It offers a few templates for creating like HAL remote user interfaces, and also maybe could create HAL configurations. It's all centered around Qt Creator to have like a single user interface that is easy to use. But however, you can also use your preferred editor, since everything is basically text files. Yeah, let's take a look at the SDK. Am I? Okay, I've skipped all the VAGRANT setup process, but it's basically you download VAGRANT, you download VirtualBox, and you clone a single Git repository. Then you run VAGRANT app. It downloads a chassis base image and runs a set of revisioning scripts completely automatically. You only have to interact when it installs the Qt SDK, because there is currently no way to install it without user interaction. So you have to click two buttons, basically. When you're done, you get this VirtualBox. Looks like this. You can find on it, yeah, it has an LXD desktop environment on it. You can find like it has MACHINEKIT installed. It has Qt Creator installed. Okay, it obviously has not Emacs installed. I've installed that myself, but that's what you get when you have the VAGRANT form running. So let's start by opening Qt Creator. One important thing is there are some certain settings inside Qt Creator that you need in order to use the QTQUICK designer. And all these settings are already applied in the VirtualBox, which is a huge advancement over over the previous state of the MachineKit SDK project. You have a few examples deployed within the SDK. The most basic example is the end demo. It's basically an AND gate connected to a button. Just have to open the Qt project. What you will get is a set of a certain folder structure, basically. It's a set of QML files plus this C++ file is basically only the QML interpreter. There's not a lot in it. It's just for importing the QML files locally. So when you remote deploy the application, you only deploy the QML files contained in this folder structure. So let's take a look at this basic example. It's just a small example of one button, two buttons, one LED, a label explaining what these buttons are doing. Since everything should work now, yes, the first time you open QTQUICK Designer, you will get this. It compiles the QML puppet, which is like a QML interpreter for the QTQUICK Designer. You have to do this every time you update QTQUICK VCP. So this is when you're, the nice thing about VAGRANT is you can configure it in a way, it comes pre-configured in this way. When you run it, the provisioning scripts, second time it just updates your repositories you already have installed. So it fetches all the updates and so on. Currently it tracks QTQUICK VCP master. It uses the MachineKit packages, Debian packages, and there are a few other repositories like the PyMachineDoc repository that are pre-cloned on this plate. In the meantime, we can start a very basic, the AND gate project. cd repos and demo. In this project, we have a run file and a very simple HAL configuration. It's a Python HAL configuration in this case. Yeah, this is still running. Always goes back in the foreground, but we can still start it, I think. Yeah, this run configuration is configured in a way that it automatically starts everything you need, so that you basically get a state that just runs. Yeah, in the meantime, the UI designer was booted, and we see that the screen is too small for this. But as you can see, things are, the preview is now working, sort of. You get a set of QTQUICK VCP controls. This is a HAL remote user interface, so it basically imitates HAL remote component. When we take a look at these components, we see we have a HAL button, a second HAL button, and a HAL LED. These have names, and yeah, all these components, clicking around too much. QTQUICK Designer is not perfect at the moment, but when I take a look at it and in the code, we see all these components have a name, and this name is used for HAL pins. The HAL application window basically mimics a HAL remote component. It also has a name, And in the end, we get a component with name and demo, and with three pins, button 0, button 1, and LED. So if we go back to the terminal and take a look at the current configuration, we see we have basically a simple end component and a remote component with these 3 pins. When we start this configuration, this user interface, we get the typical launcher type instance selection dialog. So first we select the instance. This is the instance running on the current machine. When we do this, we get directly to the user interface. Normally for the MachineKit client, we would have an extra dialog where we select the user interface. But in the case we want to develop with this, we want to create a new user interface, we typically don't want to select the user interface. So it gets instantly to the user interface once you have selected the instance. There's a way to even skip the instance selection and just use the first one you get, you find, and I can show that later. But first we prove that the user interface actually works. We have 2 buttons, so the first one and the second one are connected to this LED over an end component. So when we press the first one and the second one, the LED lights up. Very basic. And you see like this small symbol, which means that it represents that the pin is synced, meaning that it has gotten feedback or not from the HAL instance. When we take a look at the HAL instance, we see the HAL pin is true, and yeah, it works as expected. This is a HAL remote interface. Now we'll go on and show you, we'll stop the end demo, Control-C, and everything should shut down perfectly. I will go forward and go to the basic MKRepa simulator configuration, which is the Axis simulator configuration just with MKRepa, basically. When we run this, same startup procedure, we still get the splash screen. And we see MKRepa has been started. We can still use this HAL remote interface with this simulator instance, but we have no logic because there is no matching HAL remote component. So even if we press the button, the LED will never light up. But let's take a look at this HAL instance and see what we got. We got the HAL remote component. So there's a flag in the HAL remote component that says, create the instance, create the component if it exists, create the component, do not create the component if it does not exist. Depending on the application, this might be useful or not. So this is pretty useless. So we go ahead and open the second demo project, which is an application EMC type user interface. I've called it basic QTQUICK VCB. When we take a look at this source tree, it's pretty similar, but we have a few more QML files. So when we have one main basic QTQUICK VCB QML file, if the screen would be a little bit bigger, it would be easier to see. Which contains a few things. It contains the application core, which basically wraps around a few services. It basically contains all application services. It has some application notifications, which is kind of similar to what Axis does. It just shows the error message in the corner of the application. It has a remote file dialog, a normal file dialog. It has a path view core, so you can use path view components. And it has a test component, which is a HAL remote component. So to show that how this can be done in a normal CNC type application. So when we take a look at the main window, this is again a very basic user interface, but it works a little bit different. It has one button that is connected to the test HAL remote component, and the second button that triggers the e-stop. So basically the hello world of CNC user interfaces. When we start this, again, same connection dialog, and we get the two buttons. The difference between this button, which is a button that is connected to a HAL pin, and this button is that this works over HAL remote. So you can define any kind of HAL remote component you want. But this button uses application command to send the command and application status to get feedback of the current state of the e-stop button. So the source of the signal is different. When we take a look at this, how this is implemented, it's a normal button. The HAL button is similar, but for the e-stop button, we have an e-stop action, which basically hides all the things you would need to consider to implement it yourself. But we can take a look at it, and we see that when the action is triggered, an action is basically can be used for checkboxes, for buttons, menu items, and so on. So you can use this, reuse this component basically. When it's triggered, it executes an command, meaning setting the task state to e-stop or e-stop reset. And the current status is bound to the current task status, meaning the source and of the current status is different than the command that is used to set it. So there's basically a different path into what we have as machine talk services. If we want to extend this, go back to the main window. QTQUICK VCP comes with a set of standard application components. Basically, this is almost everything you need to create like a simple user interface. We have like a slider for selecting the maximum velocity, an MDI command, an MDA history table, and when we run it now, everything should connect. Okay, of course, we cannot go out of e-stop and so on because we have not enough controls here. But you see, everything gets, I can try to execute an MDI command, or cannot because I'm in e-stop. But it's pretty easy to click together a user interface with this. If you want to go deeper and like create components yourself, is a good idea to like to take a look at the source code of the components. I've pressed the F2 button, which means go to source, and you can see it's the code for a single component is usually like 50 to 100 lines. depending on the component. It's declarative code, so it's not too easy to understand in the first place, but once you get used to QML and how it works, it's pretty simple, and it's a very easy way to design everything, because you don't have to keep the control flow in mind, because the declarative nature of this language does everything for you, basically.
Can you extend that declarative? Is there a way to I mean, I know Qt also has C++. If you're not in QTQUICK, you're writing signals callback C++ style to Qt units. Is there a way to revert to that or extend QTQUICK instead of writing declarative code to write plain C?
Depends on what you need, basically. If you really need to use C++ code, it's pretty easy. Qt has a standard way to do this. You basically create a new...
But not from within the project that you just created.
No, you create a new QTQUICK extension plugin. This is an extension to QTQUICK. You just have to make sure that you deploy it to the computer that is executing the user interface code afterwards. So if you have a local user interface on a single computer, it's pretty easy. If you wanted to deploy it like to an Android device, so you have to keep in mind that you can't use the standard MachineKit client. There's currently no standard MachineKitSDK way, but I've already created a few wizards, like for creating a QTQUICK VCP project. With a sample test project. Currently, the QTQUICK VCP wizard only creates HAL remote applications. I will add another wizard for creating the CNC type applications. So it's also easy to create them without a template or example. But it's pretty straightforward to do this in Qt Creator. Just like you have a few wizards, go ahead and then you get a basic test project, which should be a Hello World type of application. Yeah, Hello World button. Again, it looks like the end demo basically. It's just like a single QML file, Hello application window, Hello button. So yeah, it's basically the Qt Creator part of the SDK. But I've also added to this VAGRANT virtual machine a few other repositories. For example, the PyMachineTalk repository. So I can also start the N-Curses user interface, which is not very impressive, but just to, yeah, it's horrible, but you can, but take a look at the status, you see the status changes. So it's a working N-Curses user interface, not very impressive, but it uses the PyMachineTalk bindings. So the idea is to make this whole SDK Vagrant thing like a place where you can go to start working with MachineKit. Not only like a QTQUICK VCP or user interface creation platform. Yeah, maybe I should show like how a deployed project looks like. CDOS or machine face. Best do this on the normal desktop. If I can get back, okay. Let's see what we get. Okay, so this is the standard MachineKit client. The sandbox computer is in the network, so I can remotely find it on the network. We have two types of detecting the services: normal multicast DNS discovery or unicast DNS discovery, where we just basically send DNS requests to certain IP addresses. This is always useful if multicast DNS is not working for some reason. But in this case, it's working. So we connected that. Then we get the second selection dialog, which we get when the instance is already running. In this case, we have one remote user interface and one local user interface. The local user interface is very simple. It just displays the running services. The remote user interface, let's hope it's kind of working. Yeah, okay, the screen is a little bit out of size. But we see all the files here have been deployed remotely from this sandbox device to this computer. And there is no need to recompile anything. You just have to use one single MachineKit client. So this is the idea behind this remote deployment. One thing that is also very new is you can shut down instances. Let's hope we get this. Yes, and you have an instance. This is basically the remote version of the Linux CNC configuration selection dialog. So here you can select different configurations for different machines. And the idea is to maybe replace the Linux CNC configuration dialog at some point. When we start a configuration, we get like a startup splash, remote splash screen basically. Then we get the user interface. It waits for the services to start up. At some point, there should appear. Can take some time. And then we get the user interface. Yeah, that's the idea behind this whole remote quick VCP thing. Okay. So what could the future bring? So this is goes a little bit forward. It's not the near future. Maybe it's more like what could be done. So first, developing HAL inside the SDK, like creating new HAL instances. Basically, it can be everything from using a text editor to like do something with the HAL remote, like creating Python code, creating normal HAL configurations, basically wizards. Then we could use the VirtualBox to simulate simulate HAL instances before we run it on the actual hardware. Yeah, we could use this virtual machine to remotely deploy to like a BeagleBone or like some other kind of SoC-based board. And of course, we can have a lot of more wizards for different things. This could be as simple, it's not simple, but something like StepGAN, the StepConf wizards, where you can just click together a machine, basically. But can also be like a graphical HAL configurator. Yeah, can also be a graphical HAL configurator. We could have live editing, which would be very nice, either editing the user interface live or editing the HAL configurations live, adding new components, removing them, seeing how their values change, and so on. We can possibly do like a software-hardware co-design. This is, yeah, very far away, I think, but maybe possible. And we could have like a HAL component store where people just can upload HAL components to create it. I mean, there's no reason why they shouldn't be reusable. I mean, yes, currently have a good set of HAL components, but there is an almost infinite possibility to create new HAL components for like special devices or like with special logic and so on. Yeah, that's it. More information can be found on GitHub. I'm working on the documentation for all this. Yeah, and thanks for your attention. Are there any questions?
I've got one.
Yep.
Can you contrast QTQUICK with something like Blade?
Okay.
Can you contrast something like Blade with QTQUICK?
Okay. Qt is basically the user interface WYSIWYG editor for GTK2.
Okay.
I'm not sure GTK3 uses something different. I think.
It's been migrated, updated. It's very different. But.
Yeah. Okay. So Qt is basically like QTQUICK designer, and the biggest difference between the framework GTK and Qt is GTK is a user interface framework. It's purely user interface. Right. So when you want to create applications or software for different platforms, you mostly have to keep in mind that the other things you want to use. Let's say, for example, what is a good example for this? A networking library. There is no networking library inside GTK, but there are good networking libraries in Qt. So Qt is a little bit bigger in the terms of it's not only a graphical user interface kit, but also has basically a way to create cross-platform applications. Another huge difference is GTK is mainly community-driven. The community is mostly only GNOME. Especially GTK3 is a strong background in GNOME. GTK2 is also used for a lot of things like GIMP and Inkscape and all these source applications, but more and more are moving towards Qt because the break in between GTK2 and GTK3 was really big, and so they have to port anyways to something different. And Qt has become like a very very good project. Basically, it's constantly growing, and with all this application and Android support and so on, it's just a better solution, a better alternative than GTK for most things. Any other questions? Okay, then thanks for your attention and stop this.